Hey everyone, in this episode of the On.NET Show, we're going to learn a little bit about how we can do performance testing with ASP.NET Core with Ryan. So stay tuned and check it out. Welcome everyone to another episode of the On.NET Show, and we're continuing our series as we dive in a little bit deeper into the world of ASP.NET Core and ASP.NET Core 3. Now, I've always been really curious about performance testing. How do I do it? How can I do it on my machine? What are some good practices that I could use and tools that I could take a look at? And so, Ryan, I'm hoping you could kind of give me a little bit of insight and, kind of point me in the right direction about how I can start doing some of this stuff.
That's right. So what I've got today is I've got a little bit of a simple recipe for how you can do some of your own perf testing, and some kind of guidelines for how should you think about doing perf testing of an app versus a framework? Because I know on the ASP.NET Core team, we talk a lot about performance. There's blog posts we publish about we're doing 50 million requests per second. We're top 10 for this benchmark, or list.add got 15 picoseconds faster in this release, and so on. It's really not the kind of testing that you can do on an application. The kinds of problems you should be concerned about with an application are different from the kinds of things that we usually talk about. So we're going to show, I've got some sample apps that are maybe not super realistic, but close enough. And we'll talk about a little bit of a recipe for testing them. And then we'll also look at some sort of example problems and what kind of evidence can we use to find that we have a problem when we're doing perf testing.
Good. Let's take a look.
Okay. So I've got a sample application here, and I've got 3 copies of it. I've got a good version, and then bad version 1 and bad version 2. So with this application, using route to code, so I'm using endpoint routing here and HTTP client, and I'm making a call to another service. So I have 2 services here. I have my forecast service and my weather service, and they're pretty simple. But my weather service is going to get some JSON from the forecast service. It's going to then incorporate that into this weather report, and it's going to send that out. So it just says hey, the weather's cloudy in Seattle, basically. Now my forecast app is a little bit interesting. And it's I'm really interested in testing the weather app here, not the forecast app. My forecast app actually has a delay in it. So it's going to respond with some hard-coded JSON, but it's also got a delay in it. Now, why would I have a delay in an app like this? Why would I do that to myself? I obviously wouldn't do that in production code. Well, the answer is to try and replicate some of the conditions that you might have in real production services. So for instance, if I'm just doing perf testing and I'm doing calls from one service to another on my machine, it's not actually a realistic scenario if they're not going to be deployed that way in production, because you're going to have some latency and you're going to have some overhead of doing those kind of network calls that aren't going to happen without that being present on your own machine, because they're just sitting right next to each other. So one of the sort of takeaways for doing this kind of easy performance testing is you're fundamentally in a little bit of a tricky situation trying to do all this testing on one machine. The kinds of things that you want to be concerned about are can I set up an actual database that I want to talk to in my perf tests? Can I set up my actual dependencies of other things that my service needs to call into or my web app needs to call into for doing perf testing? Because if you're not using your real dependencies under your real networking conditions, things are always going to be a little bit artificial. The other thing that I would say about it is you want to control for the effect of running a client and running multiple things on your machine if that's what you're doing. So in this case, one of the things that I'm doing is I've actually restricted both of these services using Docker. I'm using Docker Compose to run stuff. And I've told Docker to restrict the amount of CPU time available and the amount of memory available to both of these services. Now, the reason why I might do that is I might do that, one, to get closer to my actual production conditions. So let's say I'm deployed in app service. My developer workstation is actually probably more powerful than what I might have if I'm deployed to a simple app service instance. The other reason is to avoid competition between what's going on my computer versus what's going on inside these applications. And the other thing I would say is I'm not really testing this app to try and find max throughput. I'm not trying to hammer it with a crazy amount of traffic or anything like that. I'm basically trying to estimate or trying to think about how much traffic would my real application need to actually serve, and can we pump amount of traffic through with a load testing client that looks like what my site is going to need to serve in production, and then if I do that, are the outcomes reasonable? Is the outcome reasonable if I do that? Is the latency good? Is it crashing? Are there errors? Are things getting queued? Those kind of things.
And what's good about what you're showing here too is, even though we're specifically talking about load testing and performance testing and that types of stuff, it's probably just a good idea to have these types of defaults inside of your Docker Compose files in general. Because a lot of the times when we show demos or even look at sample code or even documentation, I almost never see anybody specify this type of information in their sample. And I'm sure a lot of folks that are watching probably are like, hey, I didn't even know you could do that. So, I mean, one, yeah, sure, it's good for us to simulate what production looks like, but probably it's a good idea too to just have these types of constraints in production so that, you can have, better control over the resources that your containers are using.
Yeah. The other thing that I would say too is it can give you obviously it's not total apples to apples, but it can give you an intuitive sense of what resources does your application actually need. I mean, you might be deploying stuff in an environment like Kubernetes where it really is a best practice to set these kind of limits, or you might be deploying stuff somewhere like App Service where you don't really determine the limits, like the system determines the limits. But it can help you develop a sense, experimenting with different values of these limits, especially the memory limit, can give you a sense of what your application needs to perform well versus what's too low of a resource limit. Like for instance, I would never, for an ASP.NET Core application, I would never go below 50 or 60 megabytes for something like this. You really will not. You might be able to do it, but you really will not get very good performance below 50 or 60 megabytes.
Yeah.
But when I've done this kind of testing in the past, and again, you have to take this with a grain of salt because it's somebody who works on the framework writing really simple apps, but I've gotten a lot of performance out of these kind of applications in the 50 to 100 megabyte range. .NET as of ASP.NET Core 3 or .NET Core 3 is aware of these settings. So when you're running inside of a container or when you're running inside of Linux, this is just a Linux feature, but happens to be used a lot with containers. The runtime actually knows what limitations it has and adjusts its behavior based on what they're set to.
Nice.
So I've got this set up here, and I've already got some things running. So some of the stuff that I've got set up that's part of my perf testing setup here is I've already launched these things in Docker Compose, and the app that I'm testing is listening on port 5000. And then the other thing here is I've got .NET counters running inside my container. So I'm going to kill this, and I'm just going to show the command. I'm going to show the command so people can see it. But basically what I'm doing here is I've put a label on my container. I'm asking Docker, find me the running weather container. And then inside of that or outside of that, I'm shelling into that container, and I'm going to run the .NET counters process here. I can hardcode the process ID of 1 because it's in Docker. But basically, I'm chaining together a couple things that exist so that I can get sort of like perf counters for this running app. If you use perf counters on Windows before, .NET counters is really similar to that. And it's a command line tool that .NET Team build that you can use to do this kind of work. So I'm going to go ahead and run something. And while this is running, we can talk about some of these counters, and then I'll talk about the command that I'm running and the tool that I'm using too. So I've got two groups of counters over here. I've got the counters that come from ASP.NET. That's this top one. And we don't have that many today. This is a set that we're going to look to sort of increase in the future. And you can see the number of failed requests. This is a total incrementing counter. So what were the number of failed requests for the lifetime of the process? You can see the rate of requests. How many requests per second am I handling? And then how many current requests? Basically, how many requests are in flight right now? And there was one, now there's 0. So there's not a lot of traffic being handled concurrently by the site. There's a lot of requests per second coming through, but they're being served pretty quickly. I've also got a bunch of counters here related to the garbage collection, so I can see the size of the GC heap, the number of garbage collections that have happened, and then a bunch of cool threading and timer related stuff, which we'll get to talk about a little bit more later. The other thing that I would highlight here is this working set. So working set is just one of the kinds of measurements of how much memory you're using. We talked about memory limits. This container has 512 megabytes of memory available, but we're only using 82. So then let's break down this command that I'm using here. I'm using a tool called Bombardier, which we can put a link to in the show notes. Bombardier is a cross-platform command line tool for doing load testing. So I like Bombardier for a couple of reasons. There are a lot of good tools out there. I like Bombardier for a few reasons. First of all, it's modern. It's built on a lot of modern tech. So it just generally works pretty well, and it's up to date with standards and things like that. It's very tunable, and it has lots of features that you'll want. So this -L here that I'm highlighting, this will output a latency distribution. So I can see what was the latency average, what was the standard deviation, and then what are all the various p-values for latency. Very important if you're doing this kind of testing. You probably shouldn't shoot for what's the max throughput I could do. You should probably shoot for understanding how much throughput you do need to handle, and am I healthy at that level of throughput? Is my latency distribution good, or are things going into the weeds? It also very clearly visualizes what status codes each request fell into. So you can see I had no errors. 400s and 500s would be errors. Yeah. I had no errors. Everything was a happy 200. And then as well, I'll bring back my rate. You can rate limit Bombardier, which is super useful, and probably someplace you should start is try to estimate how much traffic you actually need to serve, and then serve that much traffic. So if I want to serve 500 requests per second, I can do that with Bombardier. The C, by the way, is the number of connections. What I typically like to do with that is pick a somewhat high value, like 128 or 64. Those are generally good values, and you're not going to have to do too much tuning of that. So while this is running, you can see, my request per second is around 500. It's going to blip around 500 a little bit. You can see that my garbage collections are happening, my heap size is fluctuating, and my CPU usage is up at about 6%. So I'm really not making very much usage of the CPU in this application. Right. And everything, the latency is a little bit higher at 500 requests per second, but everything still seems in a pretty happy range as far as how the requests are happening. So any questions, Cecil, about the tools or the setup, or why I made this choice, or why I'm doing things this way?
I'm actually kind of just really interested in this Bombardier tool. Like in the past, I've used some other tools, like artillery and like some other types of things. So I really like the fact that you could specify the rate, because I think that one option, right, like makes a huge difference. Yeah. You know what I mean? Rather than just like completely hammering my site with like how much ever CPU I could throw at it, right? Essentially, because that's what your tool is going to do, right? It's just going to spin up and like just slam over requests. When you can actually get like some realistic numbers. Yeah. And because it's a command line tool that's scriptable, so now you could script out like these different scenarios and like collect these metrics in like, I don't know, like some document or something like that for you to analyze in like a more intelligent way. So I really like that tool.
Yeah, I'm not familiar with artillery, which is the other tool that you mentioned. Bombardier is a good one to use as a starter if you're new to this area, because again, it's cross-platform, it's pretty flexible, and it's pretty beginner-friendly. There are other sets of tools out there that I would say fall into a different category too, tools like JMeter. So a tool like Bombardier or Work, or you might be familiar with Apache Bench, those tools don't attempt to simulate a real user. So they're not very scriptable in the sense of trying to simulate how a user uses a website, for instance. Right. They pretty much allow you to do like one request over and over and over again. If you find that you need to simulate like a workflow that a user goes into, and this can get really complex, you can go really far with it. But if you want to actually test like an interaction that a user might do, you can either do custom scripts for that, or you can use a tool like JMeter, which is one that I've seen used inside Microsoft for perf testing of stuff. I think there are some others too. JMeter is one I'm familiar with. The one tool that I would not recommend is I would not recommend Apache Bench. So if you've been around for a while like me, or ab.exe, if people are familiar with it.
I've used AB.
I've used AB too. But if you've been around for a while like me, you probably know AB pretty well, and you're probably familiar with it. I would not recommend using it just because it's kind of outdated and it hasn't really been updated. So AB actually doesn't even support HTTP 1.1. It supports HTTP 1.0. And so As a result, it doesn't reuse connections in the same way that an HTTP 1.1 or HTTP 2 client would. And so it's, as a result, you're going to get like much worse perf data from AB. And it's not super realistic if you think about things like how backends communicate with each other. Your backend services are going to have long-lived connections to each other. So avoid AB, use something more modern.
Got it. All right, cool. That's good information. So now, after I've had this information, like after I've done this testing and I have my container set up, I have my sensible resources limitations and things of that nature, and I have these numbers, right? Because I think another step too is a lot of folks are like, okay, I'm just going to hammer this, or I'm going to run these perf tests, and I'm going to get some numbers. You know what I mean? If we're looking at the top right of your screen, if we head back over to the your window really quickly, like a lot of folks I know see these numbers and they're just like, okay, there's numbers, and I'm just going to like try and get them to be as low as possible. Like I don't know what they mean. Like I don't know what they do.
Yeah.
You know what I mean?
So let's talk about some of these numbers. So one of the things that is interesting about the test that the case that I'm testing, and this will probably be true about a lot of the cases that people find interesting to test, is that my CPU usage is actually going to be kind of low when I'm running the test. I'll just run it again. And we're doing 500 requests per second, but my CPU usage is actually low. Like this could go up to 100 because I've given this container one CPU to work with, but it's actually hanging around 7 or 8. And what that tells me is that the work that this application is doing is not so much in processing information as much as it is in like doing I/O, talking to other resources, which is true, right? Because we're making an HTTP client call. So you can learn from this because you can ask yourself, like, what do I expect? I know that this workload makes an HTTP call, and I know that that HTTP call is going to take some time to complete. So if the CPU usage was high instead of low, that would probably be something I'd want to look into. Like if this number were 95 or 99, my next step would be to take a profile and say, something is happening that I didn't expect. Let me figure out what's going on.
Got it.
So that's an example of how you can use these kind of things. I think the most important number for people is probably the CPU usage. Is it high? Is it low? What do you expect? As well as the latency. Like, if the latency is longer than what you expect, you probably want to start using profilers or other tools to understand what's going on. The most realistic outcome is probably if you're building like a standard web app or a standard backend sort of app, you'll probably have to do some database work because databases can be tricky to get right. And maybe we're using an ORM, or I learned SQL 20 years ago and I kind of know how to do it. Like, some of the most common problems that you're going to encounter are going to be database related, much more so than your C# code. Not that databases are bad, but like that I would start your investigation with things that are interesting or have complicated queries or have queries that are going to process a lot of data. You know your application, I don't, so I can't give you one size fits all guidance.
Sure. Awesome, man. Well, hey, Ryan, again, like you've blessed us with so much good information, man. I really appreciate you coming on. We need to make sure that we add like a lot of these tools and services and stuff like that you showed us into the show notes, so folks can definitely check it out. Particularly to the .NET counters thing. I believe is that just a part of the .NET CLI today, or is that something that we have to is that a tool that we have to add on like later on?
So .NET Counters is a .NET tool that you can install with the .NET SDK. It's not built into the .NET SDK right now, I think because we just rev it a little bit faster than the .NET SDK. And I think we wanted to make it available we wanted to make it available at a time that it didn't clearly align with a .NET SDK release. So how I'm getting that and how I'm doing that in Docker is I've done a couple things here. I've made a few small changes to make this different from what you would do with a normal Docker container, like a normal scaffolded Docker container image or something. So the main change that I'm making here is normally I would use like the .NET runtime image here or the ASP.NET Core runtime image. I'm actually using the SDK image. The reason why I'm doing that is the SDK is necessary to install .NET tools. So this is a useful thing that you might want to do in development. It's going to result in a bigger image if you use this in production. The other thing that I'm doing here is I'm actually installing the tool. I'm doing something bad and I'm running as root, which you probably shouldn't do in production, but I'm creating a folder for tools. I'm adding this to the path, and then I'm running .NET tool install here. Now, the reason why I have to do things in this order is that basically the first time you install a tool, the .NET SDK will add the path for .NET tools to the path. But because I'm not using a command shell to execute this, I'm using Docker, I have to do this manually. One improvement that the team is looking to make in the future, and I'm not sure if it will be available at the time that this video is out or not, so I apologize for that. We are looking to make there be just downloadable versions of these tools. So rather than doing this sort of dance with like, let's add the SDK, let's add this tool, let's add things to the path, there will just be a single binary that you'll be able to copy into a container that is the .NET Counters tool for this kind of debugging.
Got it. Awesome. Cool.
Yeah.
Well, again, hey, Ryan, thank you so much for being on the show. We got to have you come back on again sometime to share some more of these cool tips and tricks about ASP.NET Core sometime in the future.
Yeah, that'd be great.
So thank you all for watching. This has been another episode of the On.NET Show. We learned a little bit about how we can do some performance testing on our own machines using some tools, some command line tools, and some stuff that the team's created for us.